Let's look at this periodic table and see how metallic character increases. Metallic character increases as you go from right to left across the periodic table. It also increases as you go from top to bottom in a group. Let's remember the alkali metals, which are group 1A in the periodic table. They all have one electron in the outermost orbital. Their ionization energies are relatively low, meaning that they are very reactive. Notice that cesium is more reactive than rubidium, or potassium, or sodium, or lithium. All of the alkali metals form the +1 ion by liberating that electron. The alkali metals will react with water to form an alkali hydroxide and hydrogen, sometimes explosively. The metals will also react with oxygen to form corresponding oxides. Here are the properties of the alkaline earth metals, group 2A. They have 2 electrons in the outermost shell. Their ionization potentials are somewhat higher than the alkali metals. The reactivity is slightly different. Although they easily form +2 ions by removing those 2 outer electrons, the reaction with water is quite different. Beryllium does not react with water. Magnesium does, forming magnesium oxide plus hydrogen, but the water has to be in the gaseous state. The other metals will react with water to form the hydroxide plus hydrogen. Let's look at aluminum a little more closely. Impure aluminum is Al2O3. It reacts with hydroxide ion to form the intermediate AlO2- plus water. In the presence of acid, that is converted back into aluminum hydroxide. The aluminum hydroxide is then heated to form a more pure form of Al2O3. Al2O3 is the chemical name for the mineral bauxite. Bauxite, Al2O3, is melted in molten cryolite and then electrolyzed. At the anode, oxygen is produced. At the cathode, the aluminum is reduced to aluminum metal in the pure form. The Al2O3 is converted to aluminum plus oxygen by electrolysis. These photographs show you all of the millions of aluminum cans that are collected and can be repurified and recycled into pure aluminum again.